So what's up mga ka-ChE? It's Kuya Dale here, and I'm back with probably the last part of our chemical engineering calculations lesson. And thank you sa support that I have received of my last few videos. And thank you for all that you have shared, especially uh, people, my classmates, and also our teacher, my teacher in Quantum Review Center, Sir Lowen Borhashar. So, sir, regular ka na, sir. Hello, sir. Thank you for sharing my lessons in Facebook. Okay. So, without further ado, let's continue with our last four remaining problems in check calc. Okay. So, we have here a raw sulfur containing a 10% inert was burned using excess air and produced gas with the following Orsat analysis. And we have SO2, O2, and then N2. So we are asked to calculate the fraction of sulfur lost in the cinder as is uh, using 1,150 grams of raw sulfur was fed 1,000 moles of dry stack gas, and then calculate the percentage of excess air if theoretical oxygen is based on conversion to SO3. So this is different from what we have solved um, from the previous videos because we are solving carbon-based fuels. So burning now we are burning sulfur-based fuels, but the the purpose of burning this sulfur is to produce SO2 and then oxidizing it further to produce SO3 or sulfur trioxide, and then uh, dissolving it in water, so it will become sulfuric acid. Okay, so S now is being burned with O2, diba? So to produce SO2. Then SO2 is oxidized further, and then if you burn SO SO2, we need additional a 1/2 mole of O2 to produce SO3. Theoretical oxygen needed for the S to be burnt to SO3 is 1.5 or 3/2 of O2. And then you will have SO3. So this is what I meant earlier, that SO3 will be dissolved in water to produce sulfuric acid. And sulfuric acid has many uses in the industry, also in our home, in the laboratory. So this is the important compound that is being produced here. But now we are concerned in burning S to SO2 and burning S to SO3. Okay, so we have to solve this, diba? So let us draw the system, and don't forget also that we have cinder. We have a cinder. We have a cinder here. So cinder. If at the coal, when we were burning coal, we have a refuse. In burning sulfur, we have a cinder. So you were asked to calculate the fraction of sulfur lost in the cinder. Diba? So fraction of sulfur lost in the cinder. So how many sulfur is in here? So we have to have a sulfur balance. So like the carbon balance that we have in the coal, we have how many sulfur here, and then we equate it with the sulfur here, diba? And then we also have a sulfur in the cinder, diba? So 1.15 times 0.90, because that's also that's only the sulfur that will be burnt, and then we will be that's the sulfur. So weight, this is mass balance. So SNC, so sulfur in cinder. So we don't know that yet. SNC plus we have the sulfur here also. So 63. Nah? So this is just a sulfur balance, and then we have 1 k mole, diba? So 1,000, that's 1,000 moles of gas. And then it's we have to turn that to mass, diba? Kay mass man eh. We have to turn this also to mass. So we have 32 here. So that's the molar mass of sulfur. So we can now get the sulfur in cinder, the 513.4 grams. We have and then that's it actually. You can get the sulfur lost in cinder. So percent S lost in cinder. You have 513.4 over 1,150 times 100, and then you get 44.6%. Okay, so that's the answer for our letter A. So this is 44.6% or 0.446 because we are asked for the fraction of the sulfur. So because if we transform that to percent, we have 44.6%. So now we are asked to calculate the percent of excess air if theoretical oxygen is based on conversion to SO3. So we now have to use this balanced equation so that we can get the theoretical O2. So what we need to do here is to get the FeO₂ first. So FeO₂. Get the FeO₂ using SO3. So SO3, we have 0.9 of 1,150 grams of sulfur. Then just divide that by its molar mass. So molar mass niya, and then multiply it with the proper stoichiometric ratio. You have 1:3 halves. So 3 halves. Okay, and then you will get 48.516 moles of O2. Okay, so we have also that's the FeO₂, diba? And then we have the O2 supplied. How can we get the O2 supplied? It's from air, nitrogen. We have nitrogen, diba? So O2 supplied. So to get the O2 supplied, we just have to multiply this is 0.7921, diba? So just multiply it by 1,000 or 1 kilomole. So 792.1 siya karon over times the appropriate ratio, and then you will get the O2 supplied, which is 210.558 moles O2. Moles O2. And then you will get the excess air or excess O2 for that matter. They're just the same actually. So you have the formula will be the actual minus the FeO₂ over the FeO₂. So 210.558 minus 48.516, and then divided by the FeO₂. Then you will get 334. percent. So that's really a big percent of excess air. Diba? So that's the answer for the first problem we are going to tackling for this time. And then the next is will be the pyrite, or FeS₂, iron sulfide, also known as fool's gold. Okay, then we have 78% of that in the pyrite, and then 22% of that in 20% 22% gangue in the pyrite. This is ore. Is an ore, and it is 78% pure. Okay, and it is burned with excess air to produce a stack gas to the following analysis. So SO2, O2, N2, and then SO3. So if the cinder was found to have a partial analysis of 62.10 Fe₂O₃, so determine the percentage FeS₂ lost in the pyrite. So we are asked for that. So let me show you uh, the balanced equation for this. So we have 4 moles of FeS₂ burned with 11 moles of O2, and then 2 moles of Fe₂O₃ plus 8 SO2. So that's the balanced equation for the main reaction. But we also have a side reaction because we cannot only produce SO2, we also can produce SO3. So the balanced equation of that is FeS, just still 4 moles of FeS₂, but now we have 15 moles of O2, and then we have still 2 moles of Fe₂O₃, and 8 moles of SO3. So the only thing that's changed is the O2. So how do we solve for this? So it's actually quite difficult, but if you get the hang of it, you can solve this instantly. Okay, so let's draw the system. So we have let's name our pyrite P. So that's still the ore, and then we have excess air, and then we have cinder, and then we have a gas with the following compositions. So now we have the system drawn, and now we have to have our basis, diba? So we have a basis. It's either we can do the pyrite or we can do the gas. But for me, the easiest one would be the gas. Have to have a basis of the gas, diba? So basis is 100 kmol of the gas, or stack gas. So the way I solve this is that I write the equations. So let me write it. This is the main reaction, and then the side reaction. Okay, so how do we solve this? Okay, so it's actually you have to get the Fe₂O₃ and the FeS₂, but using this main reaction, main and side reaction. Okay, so we have in the gas, so we have in the gas, diba, 7.29 kmol na SO2. So we will put that here, 7.29. So that's the amount of SO2 that we have. And then if you get the amount of Fe₂O₃, just divide this by 8 and then multiply it by 2. So like for example, Fe₂O₃, you want to get that, you have to 729, you have to multiply that by 2, divide by 8. So that's how you can get the moles of Fe₂O₃. And let me just write it for you, what I've obtained. So that's the amount of everything in this reaction. And then we also have here in the below, diba, SO3. So SO3, naarga po muna po siya nga kini nga amount. So 1.35. So still ngadto gihapon. So from these reactions, this actually we have a so much information that we can gather here. So we have FeS₂ na reacted. So we can get that FeS₂ reacted. We have just get the sum of this 3.645 plus 0.675. We will get 4.30. We'll get 4.32 kmol. And then you have also the Fe₂O₃ produced, diba? Fe₂O₃ produced. Just add these values. You have 2.16 kmol. So you have a Fe₂O₃ na produce, diba? So Fe₂O₃ na produce is all here in the C, in the cinder, diba? Then you can get now the weight of the Fe₂O₃ in the cinder and also the weight of the cinder itself. So how you can get that is Fe₂O₃, just multiply it by the molar mass of Fe₂O₃, which is 160. So 2.16 times 160 is equal to 345.6 kilograms of Fe₂O₃. And now you can get the weight of your cinder. Just divide that by 62.10 0.621. You have the weight of your cinder to be 556.52 kilograms. Okay, so you have that. Now we have to find the FeS₂ here, di ba? Kaning nawala sa cinder. So let us rename this unknown variables to x and y. So FeS₂, let's name that y, and then your gangue or Gg, I just named Gg, gangue will be y in the cinder. Okay, so we have to have an we have FeS₂ balance, we have to have a gangue balance, and then cinder balance. So we will have 3 equations and then 3 unknowns, and then we can solve for what is asked of us. Okay, so let me just erase the all of what is written. Okay, so now we have our FeS₂ balance. So FeS₂ balance, you have 78% here. So 78% of your pyrite, diba? And then you have 4.32. You have 4.32 kmol there. So if we just add the FeS₂ na react, so we have 4.32, diba? Kini 4.32 times the molar mass, and then ato din ni gawas diri sa cinder. Okay, so kani siya muning FeS₂. So SO2 SO3 man ni. So just we related it back to FeS₂ nga nag-react, diba? And then ato din nawala sa cinder, ini x. So we have also this is equation 1, and then we have our gangue balance, just 0.22 of our pyrite, and then it's equal to y. Ana lang, because there is no gangue that was produced in the gas. So this is equation 2, and then you have your cinder balance. It's just the sum of this. Okay, so just 556.52 it's equal to the weight of the Fe₂O₃, which is 345.6 plus X plus Y. Okay, we have three equations and then we have three unknowns, and then you can solve for solving simultaneously. You can get P 729.32 kilograms. We have X 50.47 kilogram FeS₂. We have Y 160.45 kilogram gangue. And then we can calculate for the percent FeS₂ loss. So you'll get 50.47 over 729.32 times 100. Then you can get 6.92%. Okay, so it's really simple, but the analysis takes a lot of energy for you to analyze this problem, but it's really easy. I just have to have a critical thinking skills. Okay, now the easiest one in our problem set, we have a 40% oleum product contains 100 point blank percent contains blank percent sulfuric acid. Okay, what is oleum? It is a saturated, so for your information, it is a saturated solution of SO3 dissolved in H₂SO₄. So basically, same rin po na sila. Okay? So we have 40% oleum, diba? So 40% oleum. That means we have 40%. So we have to have let's have a basis of 100 grams of our solution, diba? 100 grams of our solution. So if the 40 grams of that is SO3, so that's SO3 kaya oleum dissolved in H₂SO₄, diba? So how do we get the percent H₂SO₄? So we have to have a formula. So a formula na to is so mass of H₂SO₄ formed, then plus formed A plus mass of H₂SO₄ already present. So present in oleum. Then muna rin siya ang total mass of oleum. Total mass of oleum. So mass of H₂SO₄ formed. So how do we go through that? So it's actually 40 grams of SO3, diba? And then just have to transform that to H₂SO₄ by using the molar masses. So what is the molar mass of our SO3, sulfur trioxide? So we have 80 grams. That's 80 actually. And then we have the molar mass of sulfuric acid, which is 98, diba? 98 to SO4 plus kinida yung H₂SO₄ already present, diba? We have 40 grams of that 40 grams of SO3, and then the the total is 100. So clearly we have 60. So minus lang, 100 minus 40 um, grams the H₂SO₄. Then you add that, you will get the total mass of your oleum or the percent H₂SO₄. You will get 109 or 100 grams H₂SO₄. 100 grams H₂SO₄. Or 109% SO₄. Okay? That's the answer, 109. Actually, really easy. Ma? Then we get to our next problem. The certain brand of gasoline was burned and analyzed to have a following flue gas composition of 12.4 moles of CO2, and then this will not read them anymore. And then we have cetane. So cetane, we have cetane C₁₆H₃₄. We are given the density, and then methyl naphthalene and C₁₁H₁. And then we also have we're also given the density. So we have to determine the cetane number of the fuel. So to determine the cetane number of the fuel, we have to find the volume. So volume, this the cetane number is a volume ratio of how much cetane is in your gasoline. But this the problem, this is not gasoline, it's actually diesel, di ba? So diesel ni siya kaya kanang itong crudo when the fuel in your kanang mga dagko nga sakyanan, it's for example L300 dagko nga mga pick up nga high ace they run on diesel, but also trucks daghan kayo, and also I think jeep kanang mga jeep runs on diesel, diba? So this is actually diesel kaning if you have cetane, diba? Kung cetane and methyl naphthalene, because if you get gasoline, so that's mixture of isooctane and heptane, diba? So that's a little trivia for you. Isooctane and heptane, din we have that RON to the octane number, diba? So we have also a cetane number if we are dealing with diesel. Okay, so how do we get around this? Okay, so it's actually easy. Because I've solved a lot of these problems already, and the solution just keep on coming, diba? Sana all. And also I hope you can develop that also in your mind, diba? So we have to draw the system first. So we have a fuel here. Let's call this F, and then we have our air, and then we have our G. So in the G we have 2.54%. So we don't know how many or how much cetane there is, so we'll just have to ato na lang siyang ikuan as X and then Y. So walang takabalo, let's just name them as X and Y, diba? X and Y. You have to the way we get this is that through elemental balance, diba? As you can remember in the very first video that I made a elemental balance in all each species, diba? So C, H, and O. So we now have to we also have to do that here. So the way to do that here in our problem is to get the O2 first. So we have the O2 supplied, right? O2 supplied is equal to the N2. nga N2 times this 21.21/79. So O2 supplied. Basis tayo, basis. Basis, it's actually obvious because this is complete. Di ata mag basis moles G. So supplied O2 supplied. We have the N2 82.6 times 21/79. Then you can get the O2 supplied as 21.84 moles O2. 84 moles O2. So we have to get the O2 balance. O2 balance. This element O balance siya, O balance. O na siya, O balance kay aron makuha na to. So we have 2 moles of O in O2 sa supplied from air, or that's also the supplied from air na siya. We have 2 moles of O in CO2. Then we have 1 mole of O in NCO and also in water. Don't forget the water, and then we have 2 NO2. This is free O2 kini siya. So substitute and then get the NH2O. We have 21.84 plus 2 times 12.54 plus 2.21 plus NH2O plus 2 3.09, and then you can get the H2O to be 10.21. Then we get the H balance aside. H balance it's actually really easy. So 2 NH2O. So kaning mga H dara. So just multiply this by 2, you will get 20.42 mole H. Then we have our C bal. Don't forget, just NC, just add NCO2. These are the only species that have a C in the compound, diba? So 12.54 plus 2.21. You will have 14.75 mole C. So get the overall balance now of C and H. So how do you do that? Is that you have to have C balance and H balance overall, diba? So in the cetane, we have 16 X, diba? In cetane, and then in methyl heptane, we have methyl naphthalene. Methyl naphthalene, we have 11. So just 11, and then total niya is 14.75 because that's the total C that's in our system. And then we have kini 34 na sad, 34x plus 10. Y, you have 20.42 moles. Okay? Then solve simultaneously. You can get 0.36 just a fraction na siya, fraction, and then 0.817 nga CO2 CO. So this is actually meaning moles, moles. So now we will get the cetane number. So how do you get the cetane number? We have to find the volumes first of each respective compound in our fuel, and then we will get the part of cetane there. So we have to find the volume of cetane. So we have 0.36 moles of that, and then we have to get the mass of that by using the molar mass, which is 226 grams per mole. And then we have to divide that by its density. So we have a density given in the previous slide. So get solving that, we can get 104.97 cubic centimeters of cetane. So volume of methyl naphthalene now, we have a 0.817 moles, right? Mole. Then just multiply it also by its molar mass. Then 1.025 grams per cubic centimeter. You can get the 113.18 cm cube. Now the cetane number is just it's just how many the ratio of how many parts of that like volume percent of cetane in your fuel. So 104.97 over the total plus 113.18 times 100, then you can get your cetane number to be 48.11. Okay, so the cetane number is 48. Cetane number now is 48. That's the answer of our problem. Lastly, we have the last reaction. I can't believe we're finished already. And then this is just simple. So we are given the reaction of n-butane. So this is combustion of n-butane. We are given the heat of reaction, and then determine the higher the HHV or higher heating value of n-butane in kJ per mole. So how do you get that? It's just simple. So remember this value. Actually, the lower heating value is just equal to your we have 2658 kilojoules per mole. To get our HHV, we have to multiply, we have to add our LHV and our latent heat of evaporation, or HFG. So we have the latent heat of evaporation, so lang, HVAP is 44.01 kilojoules per mole. That's the latent heat of evaporation of water. Okay, so to get our HHV, we have to just add 2658 plus, this is negative because actually pwede na to siya may negative basta kay i-add na nato siya. Okay, so i-add dili na siya ma-minus sa we have let's just minus na lang. We have 5 moles of water here, right? And then multiply that by 44.01, and then you can get your HHV to be negative 2,878.05 kilojoules per mole. Okay, So that's the answer of this problem. Okay. So I hope you've learned something in this problem, and then keep calm and ponder why you chose chemical engineering. It's really a difficult course, but still we are striving here because it's really, I don't know if I don't know. No. We are striving because this is our passion. Okay, this is really our passion. Uh, Thank you really for listening. This is the last part of our checkout lesson, and I hope that you will share this, like, and subscribe sa aming pong channel. If you haven't subscribed yet, please do so. Please leave a comment in the comment section below so that I will know how this video have helped you. Okay, so that ends now our checkout lesson. And I would just like to thank all of you for all your support. So we now have 355 subscribers. Yes. So please help us reach the minimum, and also a minimum subscribers na 1,000, and then and also the watch hours. So we have 500 watch hours pa karon. So we still have to cover 3,500 of it. So we really ask for your support, and then share and this video to others that need this. Okay? So, and also I have a request for you. Please pray for us on upcoming board exam this May 11 to 13. Hopefully kapasar na mi. We will pass so that we will become engineers already. Okay? So hanggang dito na lang. Bye-bye. Annyeong. God bless. God bless. God bless.